Section 5.2, we will look at bisectors and triangles. Looking at our first diagrams at the top, it says CD is the perpendicular bisector of AB. If you connect A to C and B to C, what is true about triangle ADC and triangle BDC? Okay, well, first thing that's true is that they're both right angles. So triangle ADC and triangle BDC are right triangles. And I can also say that triangle ADC is congruent to triangle BDC. The perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. This word equidistant means equal distance. You don't hear it too often except in math classes, but it's saying that the point will be equal distance from both line segments, or endpoints on the line segment. The converse of the perpendicular bisector theorem says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So meaning that we know we have a 90-degree angle. Okay, number 1 says CD is the perpendicular bisector of AB. Find CA and DB, explain. So if CD is the perpendicular bisector of AB, that means point C is equidistant from A and B, making AC congruent to BC. So right there I know that CA is 5 because CB is 5. And D will be equidistant from points A and B. So that makes these line segments congruent. So if AD is 6, then DB is 6. The reason I could find these so easily is because C and D are equidistant from points A and B. And we know that because we were told CD is a perpendicular bisector of AB. Okay, similar problem in number 2. It says find AB, BC, and ED. Well, if we have a right angle at angle AED, and I know that BE is congruent to DE, then that tells me that AC is a perpendicular bisector of BD. So that means that point A is equidistant from B and D. So that means these two sides are congruent. And same thing down below. BC will be congruent to DC. So let's list what we know. So AB will be 15 because AD is 15. BC will be 18 because DC is 18. And ED will be 8 because EB is 8. Okay, number 3, we want to find X, TW, and WZ. So looking at our triangle on the right, we see that WY is a perpendicular bisector of TZ. I know this because I have a 90-degree angle at Y, so I know angle WYZ is 90, and also WYT would be 90 degrees. And my figures mark that TY and ZY are congruent. So if those two line segments are congruent, then my other two line segments are going to be congruent because it makes W equidistant from T and Z. So my equation to find X will be 2X equals 3X minus 5. If I subtract 3X, I get negative X equals negative 5, or X equals 5. To find TW, just take 2 times 5, which is 10, and if TW is 10, then WZ is also 10. Distance from a point to a line. is the length of a perpendicular segment from the point to the line. So the key word there is perpendicular segment. So in the example below, which segment represents the distance from the point to the line? Well, we're looking for the line that is perpendicular. And remember, perpendicular means that the lines intersect and form a right angle. So the only answer here would be line 2. The angle bisector theorem says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So there's that word equidistant again. Converse of the angle bisector theorem says if a point in the interior of an angle is equidistant from the sides of the angle, then the point is on the angle bisector. Okay, let's look at 2 examples applying the angle bisector theorem. Number 4 says, what is the length of FD? Well, we see that CF is an angle bisector because at angle C we have 2 congruent angles. DCF and BCF are congruent. So if they're angle bisector, if it's an angle bisector, then that means point F is equidistant from B and D, meaning my 2 sides are congruent. Congruent means equal, so my equation will be 5x equals 2x plus 24. If I subtract to get x's on both sides, I have 3x equals 24, or x equals 8. Whoops, almost wrote a 5. All right, and then the question is, what is the length of FD? So FD will be 2 times 8 plus 24, which is 40. And then BF would also be 40. Okay, number 5, we're going to find X, FB, and FD. So actually it's even the same figure as the one previous. We see FC is an angle bisector, so that makes BF congruent to DF. F is equidistant from those 2 points. So I can write the equation 2x, oops, let me just fix that, 2x plus 5 equals 7x minus 37. So I'm going to subtract 2x from both sides and then add 37 to both sides. So I get 42 equals 5x. When I divide, I get 8.4 equals x. So that means that FB, oops, there we go, FB will be 2 times 8.4 plus 5, or 21.8. There's one of my answers, which means that FD will also be 21.8 because my 2 line segments are congruent. Okay, here's our last example for this section. Number 6 says use the diagram to answer the questions. A, how far is K from ED? Well, I see that K is 10 from HE, and I also see that my line segments are marked congruent, meaning K is equidistant from DE and HE. So if K is 10 from HE, it is also 10 from ED. B, what can you conclude about EK? Well, I can conclude that EK bisects angle HED, or you could also say it is an angle bisector. C, find the value of x. Okay, if KE or EK is an angle bisector, that makes my 2 angles congruent. So this angle and this angle are congruent. I can say that 2x equals x plus 20, subtract x, and x is 20. And then in D, find the measure of angle DEH. So angle DEH is the whole angle. Well, first off, let's find angle DEK will be 2 times 20, or 40. So that makes both of my angles here 40. So then angle DEH will be those two angles added together. So 40 plus 40, or 80 degrees. And that concludes our examples for section 5.2, bisectors in triangles.